Welcome everybody to the third seminar in the series of economic psychology seminars sponsored by the International Association for Research in Economic Psychology and the Journal of Economic Psychology. Today is our pleasure to have Ido Erev with us. Ido is a very well-known behavioral researcher and a professor at Technion in Israel. He has done very influential work in psychology, economics, and game theory, among other things on the description experience gap in decision-making, the use of descriptive models for choice prediction, the economic of small decisions, and today he's going to talk about humans as intuitive classifiers. So Ido, it's a pleasure to have you here, and the floor is yours.
Thanks, Carlos, for the invitation and the nice introduction. I would like to present a paper with Ellie Marks, that you can see her picture here. It's a review paper that review much of my research in recent years, conducted with Kinneret, Doron, Eyal, Uri, and Yafim. The starting point of our research is observation of a gap between basic rational decision theory, Savage's theory, and the way psychologists and behavioral economists use it. According to Savage theory, people behave as if they first judge the probability of the possible outcome of their actions, and then select an action that maximizes subjective expected utility given this belief. For example, while preparing an omelette, people behave as if they hold some belief concerning the probabilities that the next egg that they might add to the omelette is rotten. Basic research in behavioral economics, mainstream research in behavioral economics, focus on a cognitive interpretation of the theory. Specifically, this cognitive interpretation ignores the as-if part and actually treat the theory as a two-stage cognitive process: judgment and then decision-making. And in particular, most research focus either on judgment or on decision-making. This distinction, this separation of judgment and decision-making is reflected by the name of the biggest conference in this area. Society of one conference is called Judgment and Decision-Making. It includes section on judgment and then sessions on decision-making. And the European conference is called SPUDAM, Subjective Probabilities, Utilities, and Decision-Making. We would like to argue that while this, what we call JDM separation, seems reasonable and harmless, it actually is quite costly, as it's basically a slow progress. And I try to convince you that this is the case. Our main difficulty with this JDM separation is what we call the JDM separation paradox in a recent paper with Uri Plonsky. And the paradox is basically the following three observations, and I will later present examples. So basic study of judgment suggests that people behave as if they overestimate rare events. Basic study of decision-making, when they are separated from studies of judgment, suggests that people overweight rare events. However, when you do not separate judgment from decision-making, then people behave as if they underweight rare event. So there is some problem. And let me now show you an example of studies that demonstrate this pattern. The clearest evidence for studies that, or the earliest evidence for studies that suggest that people overestimate rare event come from studies by Phillips and Edwards that examine revision of opinion. In a typical study, the participants were told that the experiment is going to randomly select one of two urns that include red and white balls, and then draw some balls from one of this randomly selected urn, show them the balls, and then they have to predict, and then they have to estimate the probability that the selected urn is urn A. In a typical study, the participants were told that the prior probability that urn A will be selected is 0.5. So the experiment is going to randomly select one of the two urns and then sample with replacement 4 balls. In a typical trial, the balls are red. The first ball is red, the second one is white, and then red again and red again. Now, if you estimate the probabilities, the objective probability using base rule says that the probability that the selected earn is A is 6%, but the average response of the participant is 24%. That is, a participant overestimates the probability that the earn is A. There's small probabilities that it's A, and participants tend to overestimate it. The clearest evidence for overweighting of rare events come from Kahneman's very famous study. This is from the 79 Econometrica paper. In one of the studies, asked people to select between a prospect that will give them 5 for sure and a prospect that will give them 5,000 with probability 1 in 1,000, the same expected value. And most participants, 72%, prefers the lottery. That is as if they like the risk, or as if they think that the probability, as if they overweight the probability of getting the 5,000. In the loss domain, they exhibit the opposite pattern. They don't like the risk, but again, their behavior, most of them prefers a -5 for sure over a loss of 5,000 with probability 1 in 1,000. And again, this behavior can be captured with ideas that they overweight the 1 in 1,000 event. In both cases, they behave as if they overweight rare event. The fact that people overestimate rare event in decision in judgment studies and overweight them in decision under risk appear to suggest that people are highly sensitive to rare events. However, studies that examine choice behavior without a separation of judgment from decision making suggest the exact opposite. Here is an example from one of my studies. In this study here, just a minute. Let me see if I can move this here, it will not interfere. So in this study, the participants are asked to select between 2 keys and that appear on the screen, and they are not told, and they don't give prior information about these keys. There's 2 unmarked keys on the screen. If they select, and they are not told anything about the incentive structure. If they select on the top one, they get 0. And if they select the bottom one, they get 1 90% of the time, but a loss of 10 in 10% of the time. So for example, these are the results of a typical first 10 trials. So they can see in each one of these trials, they select a key and then see the payoff. They see the payoff in this experiment from both keys. So in all first 10 trials, the top always gives them 0, and bottom gives them +1 in 9 of the trials, 1 to 5 and 7 to 10, and in trial 6, it's led to a loss of 10. The typical result in this experiment is that even after subjects have 100, notice by the way that expected value from the risky prospect here is negative. The typical result that surprised us when we first got it, Greg Barron and I, more than 20 years ago, is that the typical results that subjects don't learn to maximize in this case, and they continue and select the risky lottery that lead to that impairs their earning about 60% of the time. That is, so this, and together these 3 results, we call them the JDM separation paradox. So without the separation, with the separation, subject behave as if they're highly sensitive to rare event, but without the separation, they behave as if they underweight rare event. One explanation of this pattern is a mere presentation effect. What we think is happening here, that when you separate the judgment from the decision making, you have to explicitly present the rare event. You have to explicitly ask what the probability that the earn is A. On here, you have to specifically write that you might get 5,000 with probability 1 in 1,000. So by the separation requires an explicit presentation of the rare event, and we believe that the observation of overweighting of rare event in judgment studies, in studies that separate the judgment from the decision making, is a result of the explicit presentation, that the separation require explicit presentation, whereas in most natural settings, when you have to make decision without explicit presentation of all the possible rare outcomes. So we think that this basic ratios that separate the judgment from the decision making can lead to incorrect conclusions that people are oversensitive to rare event, whereas without a separation, they behave as if they underweight it. In another study, we found that the tendency to underweight rare event is rather robust, and feedback eliminates the mere presentation effect. Here is one experiment that demonstrates that. In this experiment, the participants were presented. This experiment includes 25 trials. In each trial, the subjects are asked to select between a lottery that will give them 2 shekels for sure, or a lottery that gives them 101 shekel with probability 1 in 100, one otherwise. So the expected value of the 2 options is 2, the same expected value. When the subject, in the first 5 trials, the subject only have to select between the 2 options without getting feedback, but starting at trial number 6, they get feedback. So after each trial, they see how much they got. If they selected left, in this example, in trial 6, they see you got 1, you got 2, and they also get information on what would be their payoff had they select right. In this case, it would be 1. That is in 99% probability, 0.99, the payoff here will be a 1. But the participants in this experiment are informed of the payoff distribution. They know that this lottery gives them 101 with probability 1 in 100, 1 otherwise. And the results show that before getting feedback, the participants tend to select the long shot lottery, that is, behave as if they overweight rare event before they get feedback. And this is consistent with the prediction of prospect theory. But immediately after they start getting feedback, starting at trial 7 and 8, that is a second block of 5 trial here, the probability of selecting, they start behaving as if they underweight rare event. And after in the last 5 trials, they tend to select in 60% of the time, they select the 2 for sure, and they behave as if they underweight rare events. They don't exhibit the overweighting of rare event anymore. So basically, our results suggest that mainstream research that separates between judgment and decision making can lead to incorrect conclusion concerning the underlying processes. Let me show you one interpretation of this result. And this is my favorite interpretation. I like to think about research as a hike in the land of assumption in an attempt to find hills of high elevation that will give us good view of the lands of behavior, of lands of problems. And working assumptions are constraints that we put on over this hike. So basically, I think that mainstream decision research tend to hike on a land that is basically, so the working assumption is that you can separate judgment from decision making. So most research focus either on judgment or decision making separated too, and the assumption is that this assumption it facilitates research with limited cost. Based on this research, you can see from this hill, you can see overestimation of rare event, as in the study I've just shown you by Phillips and Edwards. And from this part of the land of assumption, you can see that people overweight rare event, as in buying lottery and insurance, that Kahneman and Tversky study. However, it's possible that hiking on this area will mask an important area. So if you are in this hill, you will not see what's happening here in the middle between these 2 observations that you observe. It's natural to assume, because we have here overestimation and here overweighting of rare event, that probably in this area that we cannot see from this hill that we study, that people also exhibit oversensitivity to rare event, but this is not the case. And basically what actually happened in the research that I've shown you is that in this area that cannot be observed from studies that separate judgment from decision making, this large area of natural, that I think is more similar to natural setting, in these areas people behave as if they underweight rare event. But you cannot see it if your research is constrained by the working assumption that you should separate judgment in decision making to facilitate control. And basically what we suggest that maybe research on this, maybe we should move away from this hill and try to find better hills in the land of working assumption to be able to understand the underlying decision processes better. And basically, in my paper with Eli that I'm presenting today, I suggest that there is one hill that can show us, can provide better insight, and this hill become clear nowadays thanks to the machine learning revolution. And this hill basically suggests that maybe the underlying processes is not two-stage judgment and decision process, but rather the underlying processes are more similar to an intuitive classifying machine learning algorithm. And if you look, and if you reject this separation as a JDM separation assumption, and willing to consider the possibility that people that under processes are different and cannot be separated, then you climb on this hill, and then you can understand all the phenomena. You understand when people overestimate rare event, when they underweight rare event, and this we argue is the more common phenomena, and also when they overweight rare event. And I will try to show, and what we are trying to do in our paper, and I will try to do in the current talk, is to highlight the benefit from rejecting the JDM separation assumption and consider the possibilities that the underlying processes are similar to machine learning classification algorithm. So let me try to explain what I mean by the intuitive classifier view. Basically, I argue that the violation of the JDM separation assumption can be captured with the assertion that the underlying processes resemble a machine learning algorithm. And basically, people tend to select the action that led to the best outcomes in similar situations in the past. This is basically what machine learning algorithms are doing. There's different algorithms that do it. Different algorithms find what are the most similar situation. So there are different ways to find a similarity, but this is basically what this machine learning algorithm are doing. And we argue that maybe this is what the brain is doing too. And this is how we make decision too. And I want to present 5 advantages, main advantages of this intuitive classifier view over the typical view of human decision-making as a two-stage judgment and decision-making. One advantage is about cognitive feasibility, or if you wish, computation feasibility or computation efficiency. Under the JDM separation assumption, the decision process starts by judging the probability of the possible outcome of the different action. If you think about savage omelette example, this is very reasonable. You only have to estimate when you prepare omelette. Only when you think about a specific egg, you only have to consider 2 events: either the egg is good or it's rotten. So this is not doesn't require a lot of computation power. But the set of distinct outcome in other setting can be extremely large. Even the decision whether to carry an umbrella with you is not binary event, whether there's going to be rain or no rain, but rather, there's a lot of things that can happen if you carry an umbrella. For example, the rain might be really, really strong. In that case, you definitely want an umbrella, but also the wind might be too strong. In that case, you don't want to carry an umbrella. It's not going to help you. You also have to consider the possibility that you might see a store with much nicer umbrellas than the one you have at home, and that will be great, that you don't have to carry the umbrella, but you can buy a really nice umbrella for a good price. And more important, you might consider, if you're young and good looking, well, it doesn't have to be young. If you're attractive, you might, and single, you might consider the possibility that you find a really attractive person that will offer you to get in under his or her umbrella, and this will be the best day of your life. So basically, while taking or not taking an umbrella, you cannot estimate all the relevant event, the probability of all the relevant event to do it. This is just not practical. What you can do is think about previous days like today in which you carry an umbrella or did not carry an umbrella, and think about the possible outcome of the thing. And what machine learning algorithms are basically doing, and what we argue that people are doing, they remember the most similar day to today and carry an umbrella if in those days carrying an umbrella was a smart alternative. So this really saves a lot of cognitive effort. This is one of 5 advantages of intuitive classifier view. Let me show you another advantage. Another advantage is the fact that this method is robust to incorrect description. Basically, in classical judgment and decision-making research, the assumption is that the description the experimenter is providing to the subject is accurate, and the subject does not doubt the description. If the experimenter tell him that you can earn 5,000 with probability 1 in 1,000, the subject believe it. Our argument is that in natural settings, it's very rare that you see a description that you can trust 100%, even if people don't try to lie to you. For example, nowadays, when you try to enter stores, you very often see this description: no mask, no entry. But we all know that this description is inaccurate, and just the store owners were too lazy to reduce the signal. So you see a description, but you know that you don't have to consider it. How do you know it? You know it because yesterday you enter stores that had this description and without wearing a mask, and nothing bad happened. So basically, the way we treat description can be captured with this idea that basically what you do, you see a description that reminds you similar description that you've seen in the past, and then you do your best reply. So your best reply nowadays, a year ago it was different, but nowadays when you see a description, no mask, no entry, you basically ignore it. And this is good. A year ago, you knew, especially if you were in Germany, that this is serious, you really have to wear the mask. So this is a second advantage. Basically, basic research, they assume that people always take description seriously. In natural settings, people like me always doubt a description if they read them at all. Another important advantage of the intuitive classifier idea, observation, assumption or view is that concerns the way people respond to patterns. Our results show that people are highly sensitive to patterns, even when you told them that the environment is static. And even if you tell them that the environment is static, they basically behave as if they try to look for patterns. Look at the current experiment. Imagine that you are participating in one of my experiments, and the pair from bottom is always 0, and the pair from top is -1, -1, -1, +2, -1, -1, +2, and so forth. What would you do in trial 16? Our results suggest that most participants in this case, they are looking for the pattern, and they behave as if they notice that every time after a 3 minus 1, +2 comes. That is, they don't estimate the probability of gain or loss from top or bottom, but what they are really doing, that they are looking at the recent outcome and then ask, well, trial 16 is, and basically their intuition is, well, what should I do in trial 16? Well, trial 16 is really similar to trial 12 and trial 8, because in these two trials, both these two trials come after 3 minuses. So basically their behavior, if they respond to pattern, this behavior is highly adaptive if the environment is some Markov chain or some other dynamic settings. But in static settings, people still behave as if they discover pattern when there's no patterns. And this behavior is perfectly consistent with a view that people are kind of intuitive statistician. In this case, they waste energy, even when we tell them there's no pattern, they basically waste cognitive effort by looking for pattern, and they do it intuitively. This is basically this is what our results suggest. Let me show you now a fourth advantage. A fourth advantage, and and Carlos mentioned that my co-author and I organized 4 different choice prediction competition. And our competition focused on different choice tasks, including decision under risk. And one thing is common for all the competitions that we ran, that when people can rely on feedback, the winning models in all this competition were models that assume reliance on small sample of past experiences, and this reliance can be the product of an effort to select the most similar past experiences. That is, in this setting, when the environment is basically what we suggest, that then when the environment is static, as in the competition that we ran, the effort to rely on the most similar past experience, that is, the effort to classify past experience and select the most similar past experience, lead people to behave as if they rely on small samples, and models that share this assumption provide the best prediction even for decision under risk. The fourth and last advantage that I want to present, and this is from a recent paper, and I want to focus on that paper. Just a minute. This is from a recent paper just accepted for publication in Psychological Review, but it can be found in SSRN. It still has not been published. And I think this is an important advantage of the intuitive classifier view over traditional judgment and decision-making research. Traditional judgment and decision-making research tend to explain different empirical phenomena by assuming different biases in different settings. I want to present here one example that okay, here is an example. Think about the phenomena, the observation that many people are underinvested in the stock market. They prefer safe bonds over stocks. So this behavior suggests extreme risk aversion, because in the last 100 years, stock were always the return for stock were always much higher than for bonds. But if people are extreme risk aversion, you can explain it. However, sometimes the same people who are underinvested in the stock market, when they do invest in the stock market, they prefer individual stocks over index fund. This behavior, now index fund had the same average return as individual stocks, but smaller variance. So this behavior appeared to suggest risk seeking. So how can we explain these two phenomena that appear to be inconsistent with each other? The way mainstream judgment and decision-making and behavioral economic research captures this phenomena is by assuming two different biases, and in many cases, the two different biases are related to the difference between judgment and decision-making. In this example, the common explanation for underinvestment in the stock market is loss aversion. It's a property of the decision process. In contrast, the leading explanation of the tendency to prefer individual stock over index fund is explained by overconfidence as a property of human judgment. In addition, to explain this, to explain the apparent difference between these two phenomena, previous research also suggests that which of the two biases is more important. That is, whether loss aversion is more important or overconfidence is more important is a function of the environment. In some situations, people are more likely to loss aversion is more important than overconfidence. In another situation, overconfidence is more important than loss aversion. The problem, of course, with this view that it's very difficult to predict human behavior in a new situation if you basically assume there are two biases that go in different direction, and you don't have a general model that will tell you which one of these two biases will be more important. The intuitive classifier view, in contrast, actually shed light on the condition under which people will behave as if they are loss averse, and will behave as if they are overconfident. However, this model does not have to assume either loss aversion or overconfidence. Rather, the prediction is a result of the fact that if you're an intuitive classifier and you tend to rely on a small sample of past experience, you're going to be highly sensitive to the correlation between the possible outcome. And here is an experiment that demonstrated. This experiment is actually an extension of a paper that was published in Journal of Economic Psychology, the Ben Zion et al. Paper. Basically, what we did in this study, we focused on choice between three alternatives. The participant basically were asked to select between three alternatives that appear on the screen in this experiment without there were like 3 blank options. Each time the subject selected one of the options, they got feedback from all, they got the pair from the selected option, but they also could see the payoff from the other 2 options. In this experiment, the participants were asked to choose between highly risk options that led to a gain of 8 with probability 0.5. That is, if this U that was drawn from 0 to 1 was smaller than 0.5, and -8 otherwise. This was high risk option. A medium risk option, option R, gave a gain or loss of +4. And there was also a status quo option that led to 0 for sure. Under loss aversion, people are expected to prefer the 0 for sure over these 2 options. Now the participant choose one of the options, and then, as I said, there was 100 trials, and after each trial, they see the pair from the 3 options. Just a minute. What you see here is a proportion of choices of the status quo and the risky option, the medium risk option. As you can see, in this case, the participant behave as if they exhibit a reverse loss aversion pattern. They behave as if they exhibit risk seeking. They selected the status quo only 12% of the time and selected the medium option and the high risk option much more. Okay? Notice that this behavior can be captured by a model that assumes an effort to classify past experience and select the most similar past experience. And the reason is that the 2 risky options in this example are negatively correlated. And because they are negatively correlated, if you rely on past experiences, you will never come to the conclusion that the status quo is the best option, because one of the 2 risky options, because they are negatively correlated, is always the best. When risk provide -4, high risk provide 8. And when when high risk provide -8, risk provide +4. So this negative correlation between the options leads people to behave as if they are risk seekers. Okay, just they are not they actually and this phenomena can be captured with simple models that assume reliance on small samples that does not use the words risk aversion or loss aversion. All what this model do is select the options that led to the best outcome in similar past experiences, and that's lead this model to behave as if people are risk lover or exhibit a reverse loss aversion bias. However, the same model predict, and basically we argue that a similar pattern happens in the stock market. So when you have to select between index fund and 2 risky options, relative to the index fund is like the status quo. It's never the best because it's the average of several stocks. So always a stock that is better than the index fund. And we argue that for that reason, people behave as if they underinvest in the index fund, even when we tell them when they study economics that index funds are better than individual stocks. But when you reverse the correlation, and when now you have positive correlation between the 2 risky options, then people start, in our experiment, then people start behaving as if they are loss averse. So all that we did here was to change the correlation between the 2 risky options, and now the risky option, the medium risk option, when it's never the best. When it's give 4, the high risk option is better. It's lead to a pair of +8. And when it's give -4, the status quo is the best because it's give you 0 for sure. And this phenomenon now lead people to behave as if they prefer the status quo. As you see here, the proportion of selecting the status quo is about 40%, much higher the proportion of selecting the risky option, which is only around 13%. So basically, we argue that you don't need that. If you rely on classical research, you suggest, well, sometimes people are loss averse, sometimes they are overconfident. But if you consider the possibility that there's no 2-stage process, but rather people basically select the options that led to the best outcome in similar situation in the past, then you don't have to assume 2 different biases. The same basic model, reliance on similar past experience, can predict when people will behave as if they are highly sensitive to losses and exhibit loss aversion pattern, as in the lower case. This is happening when the correlation between the risky option is positive, and they exhibit the opposite pattern when the correlation between the risky option is negative. Okay, so we don't need to assume different biases. Basically, in this paper, we consider 6 pairs of contradictory deviation for maximizations that basic research use different biases to explain each one of them. And we saw that each one of the 12 phenomena can be captured with a similar model to the one I just described here, basically reliance on small sample of similar past experiences. Okay, so here is my summary. I try to convince you, or I argue, that classical decision research rests on the JDM separation assumption. This assumption facilitates clear test of a cognitive interpretation of Savage's expected utility theory, but suffer from important shortcomings. The most important shortcoming, I suggest, is the JDM separation paradox. Basically, due to the separation, mainstream research reached to the wrong conclusion that people are too sensitive to rare event, whereas in most natural situations, when you don't separate, when you do not build your research on the JDM separation assumption, people behave as if it won't happen to me. So underweighting of rare event is a much more robust phenomenon. Next, I try to convince you that relaxing this JDM separation assumption and considering the possibility that the underlying processes resemble machine learning classification algorithm has 5 main advantages. First, this implies a much more efficient and cognitive feasible processes. Instead of estimating too many infinitely many probability of too many events, you just have to think about a similar past experience. You take a small sample, and this leads to actually very good, very effective behavior, basically what machine learning algorithms are doing. And you might also, if you do it, you might also find your lover if you're a single person and you decide not to carry an umbrella. Second, I try to convince you that this solves a problem that basic research assumes that the subject believes the description that they obtained, although we know that in real life, believing description is not a rational behavior. It's often too costly. When you get a description, you have to think why you got this description. The same model can also capture the findings that people are highly sensitive to patterns. And basically, this is how we measure intelligence, by sensitivity to pattern. People who are good in describing, capturing patterns are accepted to top universities. But sometimes the same people sometimes see patterns even when there's no patterns. And this is predicted by this approach. The 4 observation, what I wasted on much of my time in the last 20 years, is to organize our choice prediction competitions that show that this basic assumptions, these simple models that capture this approach that people are intuitive classifiers provides better prediction. So while this model can be very complex, in simple settings, they can be, as a prediction can be derived can be approximated with very simple models that won our competition. And the 5th, and I think an important observation, that this approach can help address one of the most important problems in behavioral economics. Behavioral economics find many deviations from maximization and use different biases to explain each one of them. And that's the fact that we have so many biases and we don't have a general model that will tell us which of the biases will be more important in a particular setting. This impairs predictions. And I try to convince you that much of these difficulties can be addressed by this idea that people are intuitive classifier. This is basically my story. I'm now will be happy to accept questions.
Thank you very much, Ido. We indeed have some question. Antonio Filipin already raised his hand and had a question. Antonio, do you want to ask it yourself?
Okay, can you hear me?
Yes.
Yes.
Okay, so maybe I just add something. So first of all, thank you very much, Ido, for the very inspiring presentation. I think that another reason for justifying this other way of decision, if you want, is the following. We assume that the separation of judgment and decision-making is always possible, which is not necessarily the case. So now deep uncertainty is possibly entering the radar of the economists. So in this case, we might even not know the complete set of outcomes. So judgment is incomplete by definition. And in this case, you have to decide even without, you cannot separate the two in a sense. And back to the question I was asking during the presentation, well, I slightly disagree that this high sensitivity is an advantage of the intuitive classification because possibly it's also not robust to the order of presentation of the outcomes. So you might end up making different predictions about a choice according to the order that you present to the subjects. And then if the answer is, well, that you will converge to the right one sooner or later, then my question go back to feasibility. That's not so much feasible. Okay. Thank you.
Yeah, I absolutely agree with your first comments. This is exactly what we meant by cognitive feasibility, but I think you presented it in a nicer way. Basically, we argue that the cognitive interpretation of subjective expected utility is not cognitively feasible. That is cognitive feasible to the binary choice task, and basically for 70 years now we study binary choice task. But when you try to generalize the results from binary choice task to decision between multiple when there are multiple outcomes, this really doesn't, it's not scalable. And in many situations, it's just impossible because there's infinitely many outcomes. Not in many cases, almost in each one of our the decision to take out the umbrella, there's infinitely many outcomes. I presented some of them, but each one of them, depending how attractive is this other woman or person that will, or men that will invite you to join their umbrella. And of course, to me, last time that someone asked me to join offer me to come to join their umbrella happened 20 years ago after September 11. It doesn't happen to me very often, but maybe tomorrow it will happen. So I agree with you 100% on that. Now about sensitivity to patterns, I agree. I also agree that there are situations in which people's sensitivity to patterns lead to impairs prediction. So if we are sure that when the environment is static, an effort to respond to patterns lead to deviation for maximization. In fact, our research suggests that the main deviation in this case can be captured with the idea that people rely on small sample of past experience. Because you're looking for patterns, and suppose you're now an experiment that there's 100 trials, like most of my experiments. There are 100 trials with static pair of this. You have to select in each of 100 trials with the same static pair of distribution, but you're looking for patterns. Because you're looking for patterns, you say, well, I'm now in trial number 71, but I shouldn't consider all 70 trials. I only should consider the ones that are similar to trial number 71. So you're going to throw away a lot of outcome. And in particular, if there are some rare, terrible, bad outcomes, you might ignore them and behave as if you're underweight rare events. This is exactly our explanation for underweighting of rare events. So basically, we suggest that the effort, that the tendency to look for patterns is adaptive in many situations, especially in dynamic settings. And this is basically what machine learning algorithms are doing. But human, and by the way, also machine learning algorithm, when the environment is static, then they deviate from rationality because they're looking for patterns that do not exist, and they overfit the data. And I 100% agree with you. And I also argue that the most robust deviation for maximization are this deviation. That is deviation for looking for patterns that do not exist. And this pattern is responsible for the tendency to underweight rare events.
Okay, thank you.
Thank you.
So either one question that was going through my mind, I mean, you are describing humans as intuitive classifiers in a sense as if we were pretty much homogeneous. And I wonder what are the dimensions that you think, if this way of looking at humans are right, explain our heterogeneity. So do you think that heterogeneity is in terms of how complex are the patterns that one person can match, or how long is the memory that we can draw with? Is it all about working memory? So what do you think are the determinants of heterogeneity in this view?
Yeah, thanks. I think heterogeneity is very important in two ways. One way, and this is not only a difference between humans, but also the difference between humans and other animals. I think that smart people are just better in discovering patterns. We know that for sure because this is how we measure smartness. This is how we measure IQ. So basically, much of the test, an IQ test, the most important test, is showing you some patterns and ask you to predict what the next number are going to be. So almost by definition, people with high IQ are people who are better in discovering patterns. So this is one way of individual differences. Just smarter people are better in discovering patterns. A second difference is people had different experience in their life. So if you come from a particular culture that it is never expected from you to carry an umbrella, and you are a king, and someone always suppose you are a king, and someone always carry an umbrella for you, will not carry an umbrella. Someone will give you their umbrella. So people have different past experience. Or if you are cute, really cute, then you also don't have to carry an umbrella. Some people will offer you their umbrella. So there are individual difference with a past experience that we bring with us to the lab. Basically, our favorite models assume that when you start an experiment, you rely on past experiences that happened before the current experiences, before the current experiment. And this overgeneralization or generalization from your past experience in real life. And but when you so in the first trials of experiments, what you see is the impact of past experience in similar experiment or similar experience in life. Then when you try number 71 and you already have 70 trials in the current experiment, you are more likely to rely on past experience in the current experiment. Okay, so there are at least these two type of individual difference. Of course, there are other individual differences. It could be that the similarity pattern are related to colors, and people that are colorblind will not be able to see it. Or suppose the description is written in Chinese, so some people don't understand Chinese and will not be able to use these differences. So this approach actually suggests that maybe the underlying process is general, but it's lead to different outcome because different people have different abilities in discovering similarity because of their IQ and also because of their past experiences and knowledge.
Thank you. But then is there a role for abstraction? So I was thinking, okay, we are looking for patterns and past information. Okay, first, that's going to make us very sensitive to availability bias when we don't have appropriate previous information, which is probably true. But think about the economics of big decisions. So those decisions in life that you only do a few times, you don't have anything similar to draw from. And I mean, we like to think, at least in economics, that we have a certain capability of abstraction and interpolation in order to make even a good decision in those situations where we don't have available data from comparable situations. So do you think there is a role for the capability of abstraction in this view?
Okay, it's funny that you mentioned that because, I'm an Israeli, and now in Israel, we have a situation that we've never had before, where our government behaves as if they want to destroy our economy. And I'm heavily invested in real estate. That is all my wealth is basically Israeli, is my apartment and part of my mother's apartment, house. So now I'm making, now I have to make a real decision. What should I do? Should I try to sell my apartment, And basically, I thought about it and I say, well, we had some problem in the past and nothing bad happened. But then, well, I say, yeah, but you know, my family actually come from Ukraine. And I say, well, in Ukraine, not selling your apartment was a mistake, right? So, you know, now it's the biggest decision I probably, I'm in a situation of making big decision, really important decision, but all that I can come up with is what happened in similar situation in the past. Actually, let me tell you another example. After the 2008 subprime crash, I heard a talk by Stanley Fischer, who was the head of the Israeli bank at the time. And he described how he and his ex-student, Bernanke, who was the head of the more important bank, addressed it. And basically what he said, you know, I talked with Ben. I'm not sure he said Ben, but we talked and we said, yeah, you know, in the 20s, when there was a big crash, the government decided not to support the bankers. And that was a mistake. This time, let's support them. And this is basically what they suggested. So basically, this was the biggest decision, you know, really important decision, not of mine, but of people that run the world economy or affected definitely the Israeli and the American economy. And these people basically said, okay, let's learn from past experiences. Past experience more similar to 2008 was 1929. I'm not sure exactly about the year, and do what's and we're not sure what was best there, but we know that letting the banker bankrupt, this is not a good idea. Let's not let them do that. And so far, it seemed that that decision worked well for them. I basically think that abstraction is very elegant, and people that are good in abstraction are you know, they're doing well. But what is abstraction? I think that we, in the way, at least I study judgment and decision making, we thought too much about that abstraction is to think about the probabilities and the utilities. But maybe the real abstraction is to look for patterns. And I think this is what machine learning is teaching us. You know, in the past, we thought that the best decision are people that do two-stage decision analysis. When I was a student, this is what I studied. Say, well, people are not exactly rational, but if you do two-stage decision analysis and you estimate all the probabilities and utilities, then you will make good decision and you will be able to be consulted. Now we understand that if you really want to make good decision, what you have to do is to look for patterns. Have a large data and look for patterns. Sometimes the data is not so large as in major crashes, but even then, some bankers do that.
Thank you. I have a few questions in the list. The first is from our president, Vera Rita. Vera, if you can unmute yourself.
Thank you, Carlos. Many thanks, Professor Erev. That was very interesting. There are many questions, but as a psychologist, I'd like to ask you whether you have explored the relationship between this intuitive classifier view and age. Like if you have found it in small children, even babies maybe, or younger versus older people, if that changes, or you know, if some pattern emerges in the building of or you know, in the use of being an intuitive classifier. Many thanks.
Okay, thanks. We actually, this is a great question. Yeah, well, we have data because most of our experiments were run in MTurk, so we have people of different ages, and but we haven't analyzed. This is a great idea to analyze that and look for response. But here is my intuition. I think, you know, we know that IQ tend to go down after the age of 25 because people are less good in discovering patterns, but not professor like us. Well, professor like us, our IQ goes down slower, which is good news. But at the same time, we have more experiences. So I think that this approach suggests that older people, especially people who works, probably will not suffer much. But what happened in our experiment, I think that we have data to look at. This is a very interesting open question. And I think we should definitely is one thing that I would like to study, but I'm not sure I'll get to it in the near future. But I think if people are interested, this is a great idea to a great topic and very easy to study using MTurk.
There was a question by Kan Takeuchi. Kan, if you want to ask it.
Hi, do you hear me?
Yes.
Thank you very much. I'm using machine learning to analyze the data of CPC, the choice prediction competition that you made it public. Thank you very much. Great data. So through the machine learning results, my colleague and I observe a sort of classifying behavior. That is, for some particular question, for example, for some particular question or choice tasks, people seem to be very pessimistic, where they compare, or they seem to compare the lowest rewards of both choice and A and B. So, however, the challenge lies in the interpretation. So interpretation of the results for, because I have an economics background, for theoretical purpose or modeling using equations. So I'm not so sure about how to theoretically or interpret them or the model using equation. Can you provide any guidance on how to proceed this, please? Thank you.
Yeah, well, I'm glad that you're looking at our data. Our data does show, as you discover, that there are some interesting difference between different problems. One thing that we discover that the two things going here. So the processes could be very complex. We may not be able to capture with a precise model to quantify, to provide a simple model that capture all behavior. But what we did find that, like, the main part of the data can be captured with simple models that assume that basically people rely on a small sample of past experience. In some cases, they are more they initially are more pessimistic. But basically in our competition, the winner were models that assume reliance on small sample of past experience. But I'm absolutely sure, and this is what we hope to do in our next competition, that we hope that you will participate, that one will have to come up with more sophisticated model of generalization from past experience. So maybe something in the description of the problems lead people to consider past experience in which they were tricked. Definitely, if there is ambiguity, this is happening, and we still don't have a solution for that. But this, I think, is a kind of the open questions that we hope to address in future research. And if you looking at this data, you will be in great position to for our next competition. What we're going to do in our next competition that provide more different description of the choice tags. Sometimes we will use nudge or some hints, and see how people use them, and that might help address your question.
Okay, so I agree with that, your comment. I mean, your position that process is very complex, not easy to capture by
but my point is that although it's complex, we should not give up. Simple model can still be useful, but they should not be treated as a correct cognitive model like some psychologists are assuming. Rather, the process is very complex, but we can approximate much of it with simple models. So we want to do both to understand that the process is complex, and also to find simple, abstract models that can help us predict behavior. But I want to skip the crazy assumption that the model is accurate.
I see. Thank you very much. Good to hear your opinion. Thank you very much.
So we have maybe a last question from Leo Lades, co-organizer.
Brilliant. Thanks a lot, Ido. That was really, really interesting, really great. So one of the biggest differences between your approach and the JDM approach is that in JDM, people are forward-looking when making decisions, and in your approach, people are backward-looking and make decisions. And that reminds me of a debate that behavioral economics used to have when it was compared to the old behaviorism, the Skinner boxes, pigeons, because that is also backward looking, and behavior and economics is forward looking. So in a way, I'm just, maybe it's more of a comment, but if behavioral economics can be defined as identifying deviations from the rational forward looking approach, could what you're doing here be defined as deviations from the backward-looking behaviorist approach? So where you say, well, basically you start from this idea that we are backward-looking, essentially like pigeons. You know, we don't really want to make these comparisons anymore in psychology, but nevertheless, they are also backward-looking, and they also have the same choice tasks where people pick and the pigeons select on certain buttons, but they are not as good as at pattern recognition. Decent, but not as good as pattern recognition. So could you say is basically what you do here is basically starting from that other behaviorist model and then identifying deviations from that in the same way as behavioral economists have started from economics and identified many biases from this benchmark?
Well, thanks. You revealed the fact that I'm a Skinnerian, of course. I try to hide it because some psychologists, at least 20 years ago, were thought that Skinner was wrong. My approach is very similar to what Skinner called behavior is selected by the contingencies of reinforcement. And I was Skinnerian even as a graduate student in the days that it was not popular. But I want to remind you, as you probably know, that Skinner was criticized by Chomsky and others on the ground that you cannot, as a problem you cannot solve by backwards looking. But now we know that this critique was wrong because machine learning algorithms are basically also a Skinnerian machine. You know, this is what machine learning are doing, and they can do really well. And the assertion that JDM is not backward looking also is not fully correct, because basically JDM assumes that you judge probability based on your past experiences and then you decide. So I think that backwards looking is a future. So the only way we can make decision like machine learning algorithm is rely on the data rather than invent some things. So the question is, how do you look at the data? You don't look in a stupid way, you look in a smart way. You ask yourself, in what situation you are now, and if you have a huge data, maybe not only your own data. You know, when Stanley Fischer thought about the crash in the 20s, last century, he didn't think he was not alive then, but he used this data because it's the most similar one. So thanks, this is really a good way to summarize my talk. Yeah, I think Skinner is back. I think his approach was really good. And now we understand its potential thanks to the machine learning revolution.
Thanks a lot.
Thank you very much, Ido, for a wonderful talk. It has been really great, and it has been great to see you again. Thanks for agreeing to participate in our seminar. And to everybody, the next seminar is on April 17th. We will have Marta Serra Garcia from UCSD. Thank you for being here, and have a nice evening, you all.
Thanks, Carlos. And yeah, thanks.
Bye, bye, bye.
Bye.
Thank you.
Thanks, bye.